So last time we learned, or the very last thing that we did was simplifying radicals. We're learning how we get something in simplest radical form, rationalizing denominators. So once we know how to do that, we can add radicals. And basically, when we add radicals, we start by simplifying them, and then just combine like terms. Like, you have to make sure you're adding apples to apples, sort of. And it's not unlike, in some ways, it's sort of like adding fractions. We can only combine the fraction if they have a common denominator. The way in which it's different is that with fractions, we can always get a common denominator. When we're adding radicals, we're sort of at the mercy of just seeing how it ends up after we simplify. So let's say we want to find root 2 plus root 8. Now root 2 is prime, so it's already simplified. 8 is 4 times 2, or 2 times 2 times 2. So we could rewrite it this way. And then we can simplify the second radical. So we got a pair of 2's. I know I'm looking for pairs of the same because they're square roots. So this is root 2 plus 2 root 2. And now, after simplifying, it just happens, look, they're both expressed as root 2's. I know, right? Who like, this is like, this is like Kismet here. So we have 1 root 2 that we're adding to 2 root 2. How many root 2's do we have?
2.
Nope.
Oh.
3. We're adding, it's like if I have x plus 2x, then I have 3x, right? So we got 1 root 2 plus 2 root 2, then I have 3 root 2. Now, the nice thing about these, at least these numerical examples, is we can check to see if we've done it right. So we could take root 2 and add it to root 8, and it gives me some decimal approximation, and I could take 3 times the square root of 2, and that'll give me an identical decimal approximation. So, confirmation, huzzah. I mean, we knew it, right? Yeah?
How do you do the thing on the calculator where you put the 3, the cube root?
So on the calculator, you can, if you hit the math button, option 4 is the cube root. And I don't know if this is only on updated operating systems, but option 5 here, that's where it'll say, well, if I select it, it'll ask me to put in a root. So I could do like the 7th root of 82 or something.
Okay.
If you don't have like the option to do like the x root or the nth root, you can always get it. Like if I wanted to find the 7th root of 82, you can always find it by converting the root to a 1 over 7 exponent. Another? All right, let's begin. We got to begin by simplifying these radicals, and that means we have to factor. So 24 is 4 times 6. 4 is 2 times 2. 6 is 2 times 3. Um, 81 is 9 times 9, and each of these is a 3 and a 3. So there's my cube root of 24, and then my cube root of 81. This is a cube root, so now I'm looking for groups of 3 of the same factor in order to bring one out. I can bring out a 2 from the first radical, and I can bring out a 3 from the second radical. And what luck? It just so happens that I've got 2 radicals, 2 of the same radical that we're adding together. So I've got 2 cube roots of 3 plus 3 cube roots of 3. That gives me a total of 5 cube roots of 3. All right, let's do another. This one, we're back to square roots, and this one's a little bit different just because I guess what makes us different is I've got a square root of a fraction. So we start by simplifying as usual. How do we simplify? How do we begin this simplifying that second radical? Yeah. So I'm going to do one step before that. You're absolutely right. Yeah, break it up. And then you're right. So to simplify that, we have to rationalize the denominator, and that means I have to multiply by root 2 on the top and the bottom. The root 24, I guess I probably should have made some more space because we got to simplify that as well. So 24 is, oh, we already factored that. It's up here. Yeah, but I factored 24. I still have the factor tree. Yeah. Yep. So the square root of 24, I can take out the pair of 2's, and I'm left with 6 inside. So we got 2 root 6. And what is the second, what does that fraction look like when we rationalize?
Root 6
Over 2, yeah. And we know we can't cancel or reduce this as a fraction because, of course, the 6 is inside a radical and the 2 is outside. So now there's a couple of ways we can proceed. Certainly we know that we can make some progress on this. I got root 6 in both of these. And the way that I guess I'm inclined to proceed is to say, well, I got the second term as a fraction. Why don't we make the first term into a fraction, right? Put it over 1. Just get a common denominator. So we'll multiply by 2 on the top and the bottom. So if I get that common denominator of 2, then what we have up top is 4 root 6 plus root 6. And now I have like terms on top. What's 4 root 6 plus root 6? 5 root 6. You could write it like this, or you could write it as 5 halves root 6, like 5 halves is our coefficient or factor in front. Either's fine. I heard somebody say, oh boy. Are we excited?
Oh yeah, that was me.
Okay. That's excitement? Okay. I never mistake excitement. Like I can pick up on that for sure. Are there questions on this example? Okay. More?
Yes.
Oh boy. What do we do?
Start by splitting up the fractions.
Yeah.
So for the radical.
Yeah, I think that's a good idea. You know, when we're doing this addition and subtraction, we always start by simplifying, and when we have fractions inside a radical, that means we're going to try to rationalize the denominator. So let's start that way. So we got root 2 over root 3a minus, and this other fraction, I'm going to go ahead and just put this factor of 2 on top, root 3 over root 2a. So now let's rationalize this. The first fraction needs a root 3a on the top and the bottom. I mean, the individual radicals, there's nothing to do more to simplify, right? Because we couldn't factor them any further. So that means that we're ready to do this rationalizing step. And the second one, we need a root 2a on the top and the bottom. What is the first fraction equal to after we do this? What do we have on top?
Root 6a.
Root 6a. Yeah, root 6a over 3a. minus, and what about the second fraction?
2 root 6a over 2a.
2 root 6a over 2a. Yeah. Any questions on how we got either of these results? Either of those fractions? Okay. What do we do now?
Have a common denominator.
Yeah, we're subtracting fractions. We already know how to do that. We need a common denominator. What does the first guy need to pick up?
2.
Yeah. And the second one?
3.
Yeah. So now my common denominator is 6a. On top I've got 2 root 6a minus 6 root 6a. So we have a like terms up top, right? We have the same radical. We can combine those. That gives us a negative 4 root 6a all over 6a. And look, here's an instance where we can reduce. Not because of the 6a and the 6a, but because of the 4 and the 6a. 2 goes into 4 twice. It goes into 6 3 times. And so we get negative 2 root 6a all over 3.
Do we not keep the a?
We definitely keep the a. Thank you.
Yeah.